Hello, so today I'm going to be going over inequalities and finding test intervals. So let's say we have this inequality. The first thing we can do, the first thing you want to do when you have an inequality is set it equal to 0, or get one of the sides to be 0. So to do that, I'm going to subtract 4 from both sides. And so that ends me up with 5x plus 3 is greater than 0. So we don't know what this looks like, but any graph you're going to have is going to be something like that, right? Where it crosses the x-axis at certain points. And at some points it's greater than the x-axis, some points it's less than the x-axis. And so what we want to do is find these intervals. So the points where 5x plus 3, so what we want to do is find the points where 5x plus 3 is equal to 0. So we can do that by just doing some algebra. We get 5x is equal to negative 3 divided by 5 divided by 5. We get x is equal to negative 3 over 5. So that is the case when 5x plus 3 is equal to 0. We want to find the spots where 5x plus 3 is greater than 0. So we know the only time that the function changes position between being greater than or less than 0, the only time that occurs is at these 0 points. So what we can do is we can make a number line, right? And we can say that when x is equal to negative 3 over 5, that is going to be a special point. So what we can do is check a point, any point over here. So I'm going to choose negative 10, and then any point over here. So I'm going to choose 10. So if I put in 10 for x, right, I get 5 times 10, that's 50 plus 3, that's going to be a positive number. So we know over here this is going to be a positive number, meaning it's going to be greater than 0. If we put in negative 10, we're going to get negative 50 plus 3, which is going to be a negative number. So we know this is going to be less than 0. So we know the graph for this. We know that this is going to be negative 3 over 5. We know it's going to be down here, and then it's going to change positions, and then it's going to be up here at some point. The graph is actually going to look more like that because it's a line, but just to generalize, it's going to be down here, it's going to go through 0, and then it's going to be up here. So we can say that the interval where 5x plus 3 is greater than 0, right, is going to be the interval negative 3 over 5, right, because there it's equal to 0, so we don't include it, because we're just looking for greater than 0. And then it doesn't ever cross the x-axis again, because it's only 0 at one point. So we can say that it's going to be somewhere up here for infinity. So I'm just going to go through another example. So let's say we have x squared is less than 1. What we're going to want to do is make one of the sides 0. So I'm going to subtract the 1 from both sides. So now we have x squared minus 1 is less than 0, right? So we're going to want to look at the function x squared minus 1 is equal to 0, right? We want to know the points where this function is equal to 0, because that's going to be our changing points. So you can solve this using factoring or the quadratic equation if you really want, but I'm just going to say this is x plus 1 x minus 1. If you end up factoring it out, that's what you get. And so this means that this function is 0 when x is negative 1 or when x is 1. So if we have a number line, we know that this function is going to change sign at x is equal to negative 1 and x is equal to 1. So I'm going to check, it doesn't matter what numbers you choose, but I'm going to check some number over here, and I'm going to choose 10, negative 10, 0, and 10. So if we have negative 10 squared, that's going to be 100, minus 1 is going to be 99. So over here, we're going to have a positive number. If we put in a 0, it doesn't matter which number here. I'm just choosing 0 because for me, choosing 0 is easiest. It just has to be between negative 1 and 1. So if I put in a 0, I get 0 minus 1, which is a negative number. So we know in this interval, we're going to have a negative number. And then I'm going to choose 10. Again, it doesn't matter that I picked 10. You can pick 5, 2, 1.5, as long as it's in this section of the number line. So I'm going to choose 10. 10 squared is 100. 100 minus 1 is 99. So this is going to be a positive. So we know that the graph, right, well, the graph's going to be a parabola, but we know for sure that the graph is going to be up here doing something, and then it's going to hit negative 1, and it's going to cross the line, and then it's going to be down here doing something else. And then we know at 1, it's going to be positive, so it's going to cross the line again, and then it's going to be up here. In actuality, it's going to look something more like this, but again, that's not super necessary for what we're doing. So since we're looking for when this function is less than 0, we're looking for where this function is negative. Where is this function negative? It is negative between negative 1 and 1. So our answer for this one would be the interval negative 1 and 1. And we don't include negative 1 and 1 because this is a greater than, this is a less than sign. It's not a less than or equal to sign. If we were to make this less than or equal to, I'll do this in green. If we were to make this less than or equal to, then we would have to use inclusion signs, right? Because we're including the case where these are 0. But since it's just a less than, we don't include them.